The vasculature can be likened to a bicycle tire. Sometimes the bicycle tire will spring a leak. Primary hemostasis has to do with platelets, and they can be likened to a patch for the bicycle tire. Secondary hemostasis has to do with the formation of stable, cross-linked fibrin. This can be likened to the glue that holds the patch onto the hole in the bicycle tire. Now, if an animal is bleeding excessively, we do our best to figure out why by artificially separating each part of the hemostatic mechanism. By that, I mean we'd use tests that assess primary hemostasis, the patch or the platelets, and secondary hemostasis, the ability of the body to form stable cross-linked fibrin. When discussing primary hemostasis, for this to work, we need 5 things. We need an adequate number of platelets. We need adequate function of platelets. And we need adequate and functional von Willebrand's factor. We need normal subendothelial collagen, and there must be the absence of vasculitis. So first off, we can look to the CBC to tell us whether we have sufficient numbers of platelets. Then, to test platelet function, we can do platelet aggregometry, which is basically how fast a light shining through a test tube of platelets is made more dim because the platelets are glomming up together. We can also perform a clot retraction test, where we see how fast a blood clot in a test tube shrinks and releases serum. But another way we can assess platelet function, as well as several other parts of primary hemostasis, is the buccal-mucosal bleeding time test, or BMBT. This is also known as the bleeding time test, or BT. This test is based on the fact that in a small blood vessel, like this, that develops a defect, like that, platelets are capable of stopping blood flow all by themselves. They don't need secondary hemostasis in order to keep blood from escaping from the vasculature. This is in contrast to, let's say, the femoral artery. If the femoral artery, as an extreme example of this, develops a leak, all that happens is that platelets will blow off, and we definitely need secondary hemostasis in order to fix this particular defect. So if we see petechial bleeding, we know that there must either be too few platelets, platelets must be dysfunctional for some reason, there must be an absence or a defect in von Willebrand's factor, some problem with subendothelial collagen, or vasculitis. The next set of tests we do are on secondary hemostasis. These tests assess whether the coagulation cascade is functioning, and the culmination of all of these tests is whether they can form cross-linked fibrin. We separate the intrinsic from the extrinsic factor pathway. Intrinsic, extrinsic, by artificially in the laboratory by adding different reagents to 3 separate test tubes of blood. Taking the extrinsic factor pathway first, we add tissue thromboplastin. This is a reagent you buy from a chemical company, and it contains phospholipids and tissue factor. We also add an excess of calcium to the test tube because it is required for the forward reaction. So we add tissue thromboplastin, calcium, and blood to the tube, and we wait to see how long it takes for a clot to form. That is the prothrombin time test, or PT, and it is how we assess the extrinsic factor pathway. The intrinsic factor pathway is assessed by the activated partial thromboplastin test, which is shortened to APTT or PTT. It gets its name because the reagent that is used in this reaction contains only the phospholipid portion of the reagent and does not contain any tissue factor, because of course if it did, it would be the extrinsic factor pathway that we were assessing. So we add the phospholipid, partial thromboplastin, and excess of calcium, and we make the forward reaction go until a stable clot is formed. The third test tube that may be run in some laboratories is the thrombin time test, or TT. To this test tube, we add an excess of thrombin, which is activated factor 2. So because we've skipped all of the intermediate steps by adding activated factor 2, all we are assessing is factor 1, or fibrinogen. And we add that activated thrombin to that tube and we wait for a clot to form. So this will allow us to assess the presence and functionality of fibrinogen.